CMAKE is a powerful tool capable of describing any kind of C++ projects. Doesn't matter how big it is. It can be a large scale or a very simple one. Today, I'll show you how to set up your own C++ project with CMAKE and possibly everything that you ever need to know to set up most of your C++ projects. Hi, my name is Marcos and this is Practical Software. Okay, a little bit about CMAKE. Basically, it is a versatile cross-platform build system that was meant for you to describe your C++ projects. By describing, I mean is explicitly all your dependencies, what is your source files, what are your header files, what is your interface. You can describe all of those components of a project, create some kind of package of it, and effectively instruct your compiler how to build your whole project as one thing. One funny fact about CMAKE is that pretty much like the C++ language itself, many tried to take its place, but everyone failed. It still remains the single one most used tool build system for C++ projects up to date. Of course, it's not a perfect tool, so it can get quite verbose for large-scale projects, but I have to say from experience and from what I've seen out there is that it has been really standardized, it has been improved over time, it has been growing to something that is very flexible and easy to understand and easy to get started with. So no wonder why it still remains the mostly used tool. And this is why I think it's important that we make a video about this. So today you will be learning how to install CMAKE in your environment, how to set up your first CMAKE project, how to set up your Vscode extensions, compile your first program, compile your first library, find dependencies and bring them to your project, and finally export your package, your project as a package. Everything in one single video. Let's get started, shall we? So this is my laptop. It's a Linux machine, but by the way, today's video we have a bonus because everything that I will be doing will be done inside what is called, you probably heard of it, a Docker container. The reason is, if I do inside a container, I am fully sure that my environment is completely clean. And it's also very easily portable if you want to do the same steps, with the condition that you have your Docker container engine in place. But the focus of today is of course CMAKE. So if you want to skip these first steps, that's totally fine. This is me just setting up that isolated, well-contained environment. But it's always a good opportunity to learn about it. So I'm gonna run a Docker. I'm gonna run in the background, I'm gonna leave the terminal open so the container is still alive. A Ubuntu image. I'm gonna name it CMAKE tutorial. So I have a container running on the background. Now I'm gonna open Vscode, Visual Studio Code. If you don't have it, it's really it's nice to have. And here there is a very interesting extension called dev containers. It allows me to access the container through Vscode, and from it I can invoke a terminal, I can invoke commands, I can see files, and I can, most importantly, develop as if it was a proper environment for developing. So it has auto-completion, include paths, everything is set up for us by the extension. So I have it installed, so if you don't, you can install it yourself, and this will enable that attached running container. I have a running container, so I can just click this. It's gonna pop up a new window. I'm gonna close the old one, and there I am. I am inside a container. I'm gonna create a folder called tutorial, and I'm just gonna scope to the folder. It's on the root. It's in the tutorial. There I am. Another thing, again, it's specific to the container, to the Docker environment. I can install extensions to my container from my client Vscode. Actually looks like it did it by default, so okay. The most important then are those two, of course. So I have CMAKE syntax highlight and some commands, and I have C++, which is the projects of the language of our projects. Okay, let's just get started. I'm gonna create the CMAKE list.txt. I may need to install the CMAKE itself, so this is important. So now we're speaking about installing CMAKE. So this is a terminal. I'm running inside a container. I'm just gonna do apt updates. Now I'm gonna install CMAKE, of course, and build essential. This is a package, a meta package from Ubuntu that pulls in the compiler and more build or make and more build specific things. Now we should have CMAKE in place, and now there we have it. We have syntax highlighting. Now we are getting started with CMAKE itself. So this is the file. This is the entry point of CMAKE. The CMAKE list is a file through which the CMAKE uses as it parses the file and figures out what your project is about. Usually we start with this CMAKE minimum required version. Just pick version. I think in the containers we have version 3.22, so 3.20 is fine. It depends on the project. Let's just move. I'm gonna call it tutorial. This is the actual name of my package, the name of my project. And I'm gonna add my first program. Add executable. I'm gonna call it hello. It's in the source hello.cc. This is how I usually invoke CMAKE. I usually create a build folder. I go to the folder and I do CMAKE ... This means CMAKE, look in the folder above us or behind us or underneath us and look for the CMAKE file over there. It failed as expected because there is no file such as hello.source.cc, so I'm gonna create this one. This is gonna be called hello.cc, and this is our very first C++ project. This just includes IO stream. Notice that I am inside a container and I'm getting all these auto completions, which is really nice. This is what the extension is doing for us. But again, the focus is not Docker environment yet. If you want to know more about this, I'm sure gonna make a video about it if you want. The focus is CMAKE. So yeah, this is the source file. I'm gonna create it like very simple like this. And now CMAKE should be able to find it. So again, I invoke CMAKE ... It has successfully created our make file. So I'm ready to compile. And the way we do this in a Linux environment is like this, just make. Yeah, for the sake of just seeing some stuff. Hello all. And yeah, this is already an important point. So CMAKE knows the differences. It creates a make file that figures out if there is some change. So I don't have to invoke CMAKE all the time. I usually just do it once per setup. And then I can just call make, and make knows, okay, this is a new file, this is changed, I have to compile again. And I can just call hello. Yeah. All right, now let's create a library. So a library is, for all purposes, is a special set of source files, and we can instruct CMAKE to compile a library that we can use as a dependency to another thing. So for this example, let's call hello world. Our entry point is an application. This is the entry point of our program. But I'm gonna call a function that is a dependencies from somewhere else. So usually the way I set up is like this. I create the lib folder. It doesn't have to be a lib folder. It can be anything. You can put everything in the source. It's mostly up to your organization way of working. Yeah, let's start simple. I'm gonna make a function that simply adds two numbers. Let's add two floats. Sum, float A, float B, return A plus B. This is a very simple function. Of course, I always need some header file I can pull from my application. Usually, I do it from include folder. Pay attention to the folder structure here. This is kind of a very already very standard way of working with CMAKE. So I can add my sum definition. Usually I do pragma once. And I'm gonna declare my sum. It's just this signature. Semicolon. Yes, sure. So this is a declaration. And I'm gonna use this. Okay. It's probably not gonna work, and it's part of the of this tutorial to tell you why. But first, I'm gonna add a library now. The library is gonna be called sum. It's located in the lib folder, and the source file is sum.cc. And another new CMAKE instruction is target link libraries. So the target hello is gonna be needing a dependency. The dependency is sum. So those are in CMAKE syntax. Those are targets, and we can combine them together like this. Again, I can just call make. I expect some failures. So while compiling the library sum.cc, it couldn't find the header file. Mostly, actually, entirely because it's on a different folder. So there's a way I can tell that target, look for include folders over here. So the way to do this is target include directories from sum. It's a public one, so this means that our application also needs this sum. It also needs to know where the sum is, the declaration. We can make it a private, so it's mostly for compilation of the library itself. It's not to be extended and used outside. So public is the way to go, and the directory is include. This is from the root folder. So if you look at CMAKE, it's in a folder, and it's gonna use the include folder relative to the CMAKE file, right? There is a special word for this, but let's not go too deep today. Now I should be able to find it, and it was, and I was able to compute the hello, compile the hello, and also call the library. So now I should be able to, from my application, include the same sum. I should be able to see it here, and I should be able to invoke it now. Sum of equals, I'm just gonna call sum 10. Why am I taking so long for this? 10. That's nice. End line here. This should be enough. And now I'm successfully calling a library as a dependency to an application. And this is how the CMAKE looks like. A very important thing to notice is that I didn't have to include the include folder in my application. So CMAKE knows that the library, whoever calls the library, is automatically pulling the include folder. So this is a very nice thing. It's kind of as if the library is a self-contained thing, target. And if I create a new target, like hello, and pull the library, the target, everything that is related to that target is gonna come as well. So we don't have to repeat ourselves explicitly all the components of those targets. which is really nice. What we can do next is have a external dependency. So let's say I have another project, it's somewhere in my system, and I want to use it in my CMAKE project. Usually, like I said before, many open source, many enterprise projects are CMAKE projects themselves, so we can like name gRPC is one, protobuf is one, Eigen library is one. So there are many, gtest is another one. So there are many streamlined source projects that are also CMAKE projects themselves. And the way we can connect them together is just like this. First, of course, recall I'm in the terminal. I have to install the library somewhere. I'm going to install a linear algebra library because I like it very much. libeigen3dev. So first thing, you have to have your library somewhere in your system. You could have compiled the library yourself and install locally. That is totally fine. You can compile your library, this open source library, this open source dependency somewhere in your system, like in a closed workspace, and point CMAKE to that workspace and pull from there. So many possibilities are available for us. If you install in your system, you can just call, CMAKE knows where to find those automatically, so we don't have to care about the paths. So I just installed libeigen. I know by heart how to call it, and you find this in the library documentation, in your dependency documentation. Required. So CMAKE is going to look for that. By the way, if the library doesn't exist, if the dependency doesn't exist, it's going to complain. If it exists, if it doesn't exist, you can leave it non-required. So this means that you're going to get your build files, but something may be wrong. Or you can do some checkings for conditional compilation. But for the purposes of using actually using the library, we do it like this. So CMAKE didn't complain. I can still compile it. Of course, I didn't use it yet, but I'm about to do this. So the library, it has a way to usually the supplier of the library, of the dependency, tells you how to use it with CMAKE. For this one, I know by heart as well. I hope. I think it's just like this. So this guy pulled this target, and now we can use it ourselves like this. I think it works. It does. And now I can officially use the library myself. I don't see... Yeah, of course I see it because it is in the system, but CMAKE hasn't let me know yet the actual include folders, because I know the library should be like this. This is how I add the library. And you're gonna see it works, right? I can invoke this library specific types, for example, like this. But I want to have auto-completion. It's complaining that it doesn't know where it is. The way to explicitly find those is by setting a CMAKE environment variable. It's called CMAKE export compile commands on. So if I do CMAKE like this, a new file is going to pop up here, compile commands, and the file is going to describe actually the command to compile. But this is not important for us. What is important is that we can tell our extension in CMAKE where to find this file. So the way I do is just like this, compile commands, builds relative to the CMAKE file, compile commands.json. It was able to find it. And now I should be able to resolve all the missing includes. I can even go to the library and browse it myself, just like this. So again, many libraries are just like this. And also recall that I'm inside a container, so everything is working in a container. It's surely going to work if you go to a native setup. Yeah, so I can use, the types are nice. I can use auto-completion for the library. I can just call the norm of the vector, just initialize one vector simple like this. Actually, let me print this out. cdc out. I'm gonna print the norm, put a new line here, semicolon, saving. Let me compile the program again, and I can call it and there I have it. So this is the norm of the vector, which is just square the sky, and take the root square of the sum. Yeah. And finally, let's have a look at the installation and export of a package. And by export, I mean whenever you want to enable other people to use your package with this find package facilities of CMAKE. So how do we do that? This is our codes. This is our CMAKE so far. Let's say I want to add this library as my actual target. I want to expose. I want people to use this library somehow. So it's not about this part here. It's about that library here. Well, I have produced a set of instructions already for CMAKE, so it's quick and easier that we go through them. Then I write myself, and this is how it works when you want to install and export a package. First, you install some kind of interface folder, which is our include. So whoever uses a library is going to have some header files. So this is how we install it. We explicitly tell which target we want to export. In this case, this is this library called sum. The convention is that we just put a dash here, targets. And we specify the kind of the artifacts. It's just a library, so archive. It can be a shared library or a static library. This is going to be generating some targets, and then we install these targets properly with this syntax. So we export these targets. We have the option to prepend with the namespace. And the convention also tells us that this is usually the place to put. So lib, CMAKE, and folder called with the same name of your package or target. Finally, there is a configuration file. Usually it doesn't exist yet, so I'm going to create it right now. CMAKE. This configuration file helps other libraries, other applications, other CMAKE applications find your library. So usually we have a line like this. It's basically telling whoever find this configuration file, look inside this dir, which is the lib CMAKE dir. Look for these targets, and then everything that we just exported, you have also access to. So back to this, and finally we install that very configuration file in also our install dir. This syntax will copy this file into that file. This could have been just like this, copy only. You could have some text replacement if you want to, but this is simpler. And then install that file that was generated, or should I say configured, into that one. Install that file into CMAKE lib CMAKE sum. So if I do CMAKE dash dash, there is a problem here. The problem is that we have to change this public include, so it's not very, let's say, path agnostic. So there's a syntax specifically for dealing with this. So if I am building, let's say I'm building hello depends on the sum. If I'm building, use this path as a interface. If I'm installing, this guy doesn't exist. It's agnostic to the path. So just use include. And this should do it. Now I can do like this, and I'm gonna override the installation folder so it doesn't install in my system. So the way I do it is to make install prefix equals install. I have to add the dot. Yes, now if I do make install, our package is ready. And this is the package content. So we have a library, we have our interface, we have our target description, and the configuration file telling like the entry point of the CMAKE application. Is this gonna work? Yes, it is. And I'm gonna create a client application. I'm gonna call it client. I'm gonna call it clean one. I am gonna open the folder to that client folder, and I'm gonna make a CMAKE lists out of scratch here. So CMAKE lists.txt. As usual, CMAKE minimum required version 3.20, project client. And this is where the magic happens. Find package. Our package was called sum. Is the name of the file that it's gonna look for. Just for a reference, let me do it like this. It's not gonna find it. I'm gonna create a new terminal from client. Yes. Make the build. We've seen this before. It's looking for that file, some config. It can't find it because it's not on my system. I have to either install that package that we generated before in the system, or I point CMAKE towards it. So the way I point to the correct dir is just like this. CMAKE CMAKE install prefix. This will tell CMAKE where to look for. So this is root tutorial. It's in build install, and this should be enough. Look at that, it was able to find the library. Is it really? Yes, it has. Nice. Okay, let me add this very stupid code to invoke it. I'm gonna call it client CC. I'm gonna use stream to print some stuff. I'm gonna include that sum.hh, which is the dependency. And I'm gonna call it dc out sum equals sum 0 to 0 n add executable client.cc. I haven't created a folder, so this is enough. Oh, this is a make. It didn't find. Of course, I have to link it. Target link libraries client. What is it called? We call that namespace. This is where we use it. Something colon sum. Look at that. We just pulled the library that we created before. Again, CMAKE doesn't know where it exactly is. It knows when compiling, but doesn't know when using this auto completion. So we've seen this before. Also, good refresher. Export on. Then I open my configuration, Ctrl-Shift-P, JSON. I go to that file, compile commands, build, compile commands.json. Did I write it right? Yes, I think I just have to do this now. Okay, generated. Amazing. I can find a library. And it knows what it is. You look at that. It knows it's in install folder in the root directory, build, install right there. And I can invoke it. And I don't know the source code of this because I exported just the header file, but yeah, the linker is doing its job to find the symbols and making it work. That is it for the video. Thanks a lot for coming, and I hope you have learned something new. See you.